2. If you're on 598, you're at the right spot.
These would all new vocabs, right?
We're starting new. We didn't have a lesson over the weekend, so there's no vocab words from Friday's lesson this time. Let's just get some ideas here on vocab from this one. Everything I see so far, there's no blue words. Is there some old words we need to kind of think about? Yeah, you got to know what a polynomial is. You got to know what a root is, but wasn't that on your quiz last week?
Yeah.
Okay. I see the discriminant being talked about at the bottom of page 598. The discriminant. The rational roots theorem is in bold on the next page, 600. Rational roots theorem. We hit it, but it's officially new today. Okay. So, back to 598. I think that's all the words you guys are going to be worried about. Finding roots. Part A, it says find the real roots of the polynomial. Okay? Now, roots mean zeros is important to start these. Okay? Because there's no 0 put in for y yet. If you look at their first step, if we're finding roots, they tried to factor it. It's a perfect cube minus a perfect cube. Okay?
I don't like that they didn't show zeros, so let's do this the way I'm doing it.
And it's not going to be much different. But if they say roots, I hope you're thinking I'm putting a 0 in for y. How many roots should it have?
3.
3. Good. Why, Mo?
Because the highest power is 3.
Perfect. Will they all be visible x-intercepts if you happen to graph this thing?
Not necessarily.
Not always. Good. Paul said not necessarily. Could it go hit, hit, hit again? Sure it could. Does it have to? No. For example, it might do this. It might swing, swing, swing and only have one root. It might swing, swing, swing and have 3. We don't know yet. Okay? Y equals x cubed minus 27. Is that correct? Find the roots for me. That means y is 0. Find the roots. We hit this last week. I think it was early in the week, where it was late the week before. That's a perfect cube. That's a perfect cube. We have a tip. We have a trick for factoring perfect cubes. It involves a binomial times to a trinomial, and we're ready to rock. The cube root of x cubed is x. The cube root of 27 is 3. I've almost built my binomial already. The sign you see is the sign we want to see here. They match. Plus up there, plus right here. Which means we can build these signs now. Whatever these signs were, this one's the opposite. This one, I'm just going to write always a plus. There's a lock. That's the only one that's locked. The trinomial is built off of these binomial pieces. Okay? To build the front, square the front. Okay. To build the back end of your trinomial, square your back end. 9. To build the front, square the front. To build the back end, square the back end. To build the middle, just slam these two together with multiplication. 3x. That's it. You just factored 2 perfect cubes that were subtracted. Okay, so I can already tell you one root. That first binomial factor has a solution at x equals 3. I just use solution. Root, solution, 0, x-intercept. 3 is one of them. Will you see that one graphically? You will see that one. That's a real number, right? It's this piece here that we don't know about yet. There's still 2 more roots that have to come from this one. Mo said there's going to be 3 roots. We've only got one of them. Okay. So, we love it if that factored. But just preview the problem with me. Isn't it going to have to be 9 and 1 on the back end? Or 3 and 3? Does 9 and 1 add up to 3? Does 3 and 3 add up to 3? This won't factor. Or hey, what do we use when a quadratic won't factor?
Quadratic formula.
You got it. Quadratic formula. I'm going to write it out for you guys that are still trying to get this quadratic down pat. There it is with nothing plugged in. There's the formula. When it won't factor, we go there. And also remember, I'm going to upload this today. So if you're struggling keeping up with your notes, you got all the time you need to go back and pause me, right? Write it down. You don't need to rush right now. My A is 1. Right? There's a 1 hide right there. So every A needs a 1 times 1 times 1. Every B needs a 3, and it needs to be positive. Well, this says switch your B. Well, what's the opposite of B? If my B is positive 3, what's the opposite of my B? Negative 3. And again, 3 goes in here and becomes a 3 squared, which will be 9 in a second. C's 9. Well, there's only one C in here. Plug them in. X equals negative 3 plus or minus the square root of something I'm going to clean up right now. 9 squared is 81 minus 36. All over 2 times 1 is 2. Which is negative 3 plus or minus the square root of 45. All over 2. Which is negative 3 plus or minus, I gotta break that sucker down. That's what, 9 times 5?
Mr. Wally, you're supposed to do 3 squared, so that's 9. You're not supposed to square the 9.
Oh, crap. Thank you.
Wait, what?
B was 3, B wasn't 9. So let's go back and fix this. 9 minus 36 is gonna have something happen that we need to make sure we know what that means. Alarm, 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 right here. What do you know when you get a square root of a negative? They're going to involve i's, right? Will you see these other 2 solutions graphically? Nope. We would call them complex solutions. Let's show you the best we can do cleaning it up. The square root of 27 will clean up into 3 radical 3. Because the square root of 9 times the square root of 3 would make the square root of 27. I don't know the square root of 3, but I know the square root of 9. The negative underneath now becomes an I outside, so you guys already brought that up, all over 2. Now, since 3 and 3 are not divisible by 2, I can box these. There's 2 solutions that are complex, right? 1 real solution. So kind of finishing it up, it says find the real roots. What do I need to box then? The only thing I did box. I'm not boxing that. I found them. I needed to find them, and once I got right here, I knew I didn't need to box them. They weren't real, they were complex. Right? Find the real roots only. The other 2 were complex. Not real. Any questions at that point? Okay. Part B, find the real roots of this one. Well, that's a perfect cube plus a perfect cube. All right. B, would you look at B and look at the next page, 2A? Look how close they are to each other. X cubed plus 64, 2A, x to the 6th minus 64. I'm going to do 2B just because that x to the 6th is going to screw with somebody's head. X to the 3rd, we've already dealt with x to the 3rd, perfect cube trick. We're going to use that same trick on example 2A. I said B, I meant 2A.
But because that x to the sixth is starting it off with a minus,
And they've already put the 0 in this time. That's still a perfect cube. The cube root of that is x squared. That's a perfect cube. What's the cube root of that? Not the square root. Cube root. 4. So we're using that same trick. Binomial. Trinomial. All right. Cube root of the front. All right. Again, if you need a thought, where did that come from? It came from power over root, which would be power over root. X squared. Minus needs to match. Cube root of 64. Cube root of 64 is 4. Here, to build the front, square the front. To build the back, square the back. To build the middle, smash them together with a multiplication. 4x squared. Let's finish our signs. We know this needs to be the opposite of those two. Add. This one's always a plus. How many roots should we end up with? 6 roots. Cool. Does that look familiar? It's not a perfect cube minus a perfect cube, but it's a perfect square minus a perfect square, which will factor into older trick, perfect difference of 2 squares. Well, I can now tell you one root, and it's real. I can tell you a second root, and it's real. But there's 4 more roots left, right? When I look at this, I have to do something different, because that's not a quadratic, and they have nothing in common. So we're going to have to factor that, and if you check it out, page 599, top example, they said if you graph this quartic factor, quartic, if you just type that in and looked if it hit the x-axis, you would see that graph. Does it hit the x-axis?
No.
No. Now, could we take the time to possibly figure out the factors of this and figure out that they're all complex? We could. But what they're saying is that that leftover factor is a little bit ugly. Type and graph it, and you'll realize it doesn't have zeros. Right? That blue curve has no zeros. So we found 2 zeros from our first factor and no zeros from the other. They would all be complex. 4 complex because the graph never hit the x. This graph would have hit the x twice, and we got them. So it's like you're doing a graph and another graph. Zeros, 2 of them. None of them. So you have a second option. Over there we were able to use the quadratic formula on that second piece. Here we weren't, but by typing it in and seeing that it doesn't hit the x-axis, we know that they're complex there, all 4 of them. They didn't ask us to solve it, right? All right. Just talking through example 3, and we're probably done for the day as far as this goes. Example 3 looks a little scary until you realize, find the real roots of a 4-termer, graph it. Cool. You graph it, you're looking for x-intercepts. This thing is a little whammy-looking shape. You can see the graph right now. That hits at some x, and we have to approximate that off of our calculator, 2 point whatever it says. So you've got options. Calculator's an option. For these, that you're going to feel it. When it's a quadratic, you're going to feel, I can get those zeros. When it's a quartic, I hope your brain's saying, I'm typing that one in. When it's a 4-termer cubic, like example 3, I'm going to type that in. And what are you looking for? You're looking for zeros, which are x-intercepts, which are solutions, which are roots vocab from last week. Right? Any questions? I know you guys can't ask them. Point at the camera. Any questions from you guys? What was the part 2? They're a little bit more complex equations, right? We're used to more of this and less of that quartic. That was weird. Cool. Let's get you some numbers. I'm going to put them up as I find them. And Jeremy, just keep her going here. Find a spot. So they can see it tonight when they get home. Lesson 85. Still got you a bunch of time here. A through H would be great. H. You guys can get started on that, except for Jeremy. Let's get you some rest of them. We want to do 5. We want to do 8, 9, 10, 12. 17, 18, 7. There you go. You got that good focus, Jeremy, when they'll need it for a couple seconds, they can pause it. Perfect.